15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again and welcome. Thanks for joining us on the Space Nuts podcast. This is episode 251. I am your host, or just the idiot at this end of the proceedings. Andrew Dunkley is my name, and joining me is always the expert in everything, the Russ Hinds of astronomy.
The idiot at the other end of the line.
Fred Watson. Hello,
thank you,
Fred.
Thank you, Andrew. Good to see you and hear you again this morning.
Now, I should qualify what I said about Russ Hinds for everybody overseas or who doesn't live in Queensland, but Russ Hinds used to be a state minister in the state of Queensland many years ago, and Russ was referred to as the Minister for Everything because he had so many portfolios. So, yes, I suppose in the United States you'd call him the Secretary of Transport, the Secretary of Communications, the Secretary. He had all these portfolios. So we just referred to him as the Minister for Everything. Quite a character in the history of Australian politics, he was. How are you, Fred?
Very well, thanks. Yeah, all good. Down in Canberra yesterday.
Nice to see you. Yeah, would have been cold.
And it was just wet. When I went down on Monday afternoon, I went through horrendous thunderstorms, and it just rained from then. And in fact, my drive back last night was in rain all the way. I might just mention, though, that I was down there. One of the reasons why I was down there was to attend the opening celebration of Questacon's space exhibition, the new Questacon in space, which is open to the public as of today. Any Australian listeners who happen to be going through Canberra, you can visit this fantastic new exhibition, which is a duplicate of the one that Questacon recently provided for the Australian Space Agency at their headquarters down in Adelaide. So two versions of the same thing.
Well, I plan to see the one in Adelaide.
Yeah, you said so, yeah.
In September. So don't let me forget.
No, I won't. I'll remind you.
Don't let me. I really want to see
good.
that. Yeah.
Yeah.
Now, coming up on today's episode, we're going to look at the expansion of testing of Ingenuity because so far so good. 4 tests down and looking fantastic. We're also going to talk about the Quasar satellite. And it's not what you might think by hearing the word quasar. We'll also be discussing false positives when looking at exoplanets and finding oxygen and going, oh, oxygen, there are people, there's life, everything's, no, possibly not. And space blobs. Space blobs are probably the most exciting thing we've talked about in a while. Space blobs. They do exist. And questions from Bill in Michigan about the Lorentz-FitzGerald contraction. That's how stars give birth. And Chris in Canberra has some ideas on how Starlink can help in other ways aside from providing the internet. So we'll tackle all of that today on Space Nuts. But first, Fred, yes, as has been sort of common practice for us the last few weeks, another situation with Ingenuity. 4 tests down, all highly successful. They're starting to think beyond test 5, which is the pizza delivery test, and start to do things that are a little bit more radical, I suppose.
Yeah, this is fantastic news, Andrew. That NASA are so pleased with the performance of the helicopter in its first 4 test flights. And, there are images very easy to find on the web of Ingenuity doing its thing, as well as a lovely portrait of the two of them together, a selfie taken by Perseverance, which has Ingenuity on the ground right next to it. Lovely stuff. They're so pleased that they've extended the mission. I think by another month. That might not be the case, but it's certainly beyond the first. It was all supposed to be over by effectively, the first week in May. But what is really interesting is that NASA think they've identified another landing site for Ingenuity, and it's in an area that's of interest to Perseverance as a place to explore. And so what we might see is Ingenuity heading off and landing in its new site, getting overhead imagery, and Perseverance trundling along to follow it and do the follow-up exploration. I think there are some really interesting rock sites that they've identified, rock strata, exposed rock, which is really what Perseverance is all about. The main mission is to go and climb up onto the Jezero crater delta, but they're in the foothills of that delta now, or the foothills of the deposits that it left behind. So there's probably already stuff that might be interesting. So we're actually seeing, it looks as though we're seeing Ingenuity doing what they said it wouldn't do because it was just a technology demonstrator, but actually doing some scouting for Perseverance.
Yeah, that's great. I think it's, if you've got the opportunity to do it, do it. I mean, if the thing crashes and burns trying to, achieve something extraordinary, that'd be sad, but probably worth the effort. You never know what they might be able to achieve just by extending this operation to a whole new level. I think it's fantastic, and they've done brilliantly so far.
Yep.
I hope the whole thing doesn't sort of fall into the laps of bureaucrats and Perseverance is, trundling along, following Ingenuity, and they go, "Oh, look, there's a fossil. Yeah, we're not going there. Keep going."
Actually, I think they're a bit more pragmatic than that when it comes to space exploration.
Yeah. All right. So we watch with continued interest at the experiences and whatever of the Ingenuity helicopter. Now, let's move on to the next topic, which is that of the Quasar satellite technologies, which could see a revolution in space communications. This sounds very exciting, Fred.
It is, and the reason why I'm happy to mention this is because it's a great example of the transfer of technology from astronomical projects into the commercial world. And that's one of the things that certainly modern governments are always looking for. They're looking for the spin-offs, they're looking for the feedback into everyday life. And, well, we've seen examples of it already with Wi-Fi, which started its life as a technology developed for radio astronomers. Once again, the radio astronomers have come to the party with this. So Quasar Satellite Technologies, a private company, but it's a spin-off from CSIRO, which is Australia's national science agency. And of course, CSIRO operates things like the CSIRO Astronomy and Space Science, which operates ASCAP, the Australian Square Kilometre Array Pathfinder, along with other organisations. But for their radio telescopes, CSIRO have developed technology called PAFs, phased array feeds, and they are in use on the ASCAP array, the Pathfinder array of dishes, which is in Western Australia. And what they are, Andrew, is it's like a fancy radio speak name for what we would call an image sensor in the world of optical astronomy, the kind of thing that's in your mobile phone, but senses images rather than radio waves. So a PAF is an image sensor, but for radio frequencies. And they have essentially revolutionized the way radio astronomers work, because traditionally radio telescopes look at one point in the sky. If you want to build up an image, you've got to scan, take your data at many, many different points, moving the telescope, and then building up the image. But PAFs allow you to, as we do with a camera sensor, they allow you to take the image in one shot. So what's now happened is with Quasar Satellite Technologies, this spin-off company from CSIRO, they've turned things the other way around. They are now proposing to use phased array feeds, these PAFs, but to use them in satellite feed dishes. In other words, the ground stations that talk to satellites, if they're equipped with these phased array feeds, it means one, one dish on the ground is not just limited to talking to one satellite. It can do it for many simultaneously. Wow. And so you hugely improve the bandwidth of your communications. And it plays directly into the thing that we've talked about before, and we'll talk about again, the mega constellations, which we're now seeing being launched, all these huge numbers of sataelites. If you've got several tens of thousands of satellites in orbit, you don't have several tens of thousands of down stations, the dishes that need to talk to the satellites, but the phased array feeds will actually solve that problem. So really interesting technology spin-off there. Very happy to mention it.
It sounds like a fantastic sort of move towards simplifying what was, I suppose, a task that was pretty plodsome. You just you had to do one thing at a time. Now you'll be able to do multiple things simultaneously, which is always beneficial when it comes to working in space. No doubt about it.
I think
that's great news.
I think plodsome is the word of the day, Andrew. That's a good one.
I'm going for word of the year, but I think Jab will get it.
Yeah, that's
unfortunately.
No, plodsome. That suits me perfectly.
Plodsome, yes. Sounds English. Yes. Now, let us continue on, because we've got another story that's hit the news this week in regard to the search for life on exoplanets, or exomoons for that matter. And that is, we may well find planets with oxygen atmospheres and immediately think, oh, you ripper, that's got to be a place where life is, and we shouldn't get too excited about that.
That's right. It actually, it plays into a bigger picture question, Andrew, because this whole issue of what constitutes a biomarker, and that's an unequivocal sign of life processes, that pervades the whole of astronomy and space science. There's been huge debates, for example, in relation to perseverance, in terms of what actually is it looking for? What could it find that will be unequivocal evidence of life? And it turns out there aren't many things. There's one or two things that are very pointed towards life, and in fact one of the ones I love is things called Mickey Mouse ears stromatolites, which are rock formations with Mickey Mouse ears. They look exactly like it. The strata are bent up like this. I've drawn a picture of them for my new book, in the children's book, as you would with a name like that. But they might be, they're thought to be something that will be very difficult to explain without biological processes. So the same sort of thing happens when we talk about exoplanets, which before very long we'll have the capability to image directly and look at the signatures of gases in atmospheres. And we've talked for a long, long time about the possibility of biomarkers turning up in those atmospheres, and indeed possibly technomarkers, or technosignatures they're sometimes called, which will be something like chlorofluorocarbons in the atmosphere of an exoplanet that only come from industrial processes. So you're absolutely right. Oxygen, we believe, on our planet has mostly originated because of bacterial emissions. Several billion years ago, I think it was about 2 billion years ago, that the oxygenation started. I can't remember the numbers, but we think that most of the oxygen is from plant life, effectively. And so, that's a nice step to say, well, if you find oxygen in the atmosphere of a rocky exoplanet like ours, is it a guarantee of there being life there? And that's what this new research is about, because the answer is no. There are several alternatives. This is some work that comes from University of California, Santa Cruz, where they have identified at least 3 other mechanisms that could cause an atmosphere to be oxygenated without the need for life processes. So the bottom line is that oxygen is not enough. Once again, astrobiologists have been talking about this kind of thing for a while. What you really need to look for is oxygen which is out of equilibrium with some other gas, for example, methane or carbon dioxide, you're going to be not just looking, waving the flag, yay, we found oxygen, we've discovered life, but you will have to find other gases that complement it, and together, which are much stronger evidence of life processes.
The other telltale sign of life in other planets is approaching intergalactic ballistic missiles. That would be.
Well, nature throws those at us as well, actually. So even that's
true.
They're called asteroids.
Yes, very, very true indeed. So when it comes to identifying these markers, we're going to have to double check, because it won't absolutely mean that there is probably life there. Although, as you and I have discussed many times, the probability is we will find it. There will be places that have microbial life or something. I imagine, I'll take another giant leap and say, I imagine there's probably planets out there that have a primordial soup and perhaps have reached the algal stage of evolution. I would like to think that. I know a lot of people believe that there are probably planets with civilizations that are nearly as advanced or more advanced than us, but we would never find them. That's the saddest part of the whole story. Even if they do exist, and there's so much to say probably not, we will never know about them unless we or they come up with some incredible technology through particle physics to bend space and time and just sort of do a giant leap from one part of the universe to the other and say, oh, g'day, how you going? Look, can you tell me how to get to the petrol station? Or something like that.
So to qualify that, it is certainly possible that we might know about them. Because of technomarkers or biomarkers, there will be ways, like the discovery of CFCs in an atmosphere, or like the sensing of radar signals or something like that. But you're absolutely right. The chances of us being able to walk up there and knock on the front door, just because of the distances involved, that is a much smaller prospect, and that might be a good thing. If we look like tasty morsels to some of these advanced civilizations.
Well, look at it from another perspective, Fred. We have a history of hostility. We are not nice people. No. I don't think I'd want to be a part of a civilization where we turned up, because we know what we're like. There's always that issue that confronts us as human beings. Our nature is not always well-meaning, if I can put it that way. Would that be a fair assumption?
Yeah, I'd qualify that. There's a new book just out by somebody who specialises in this kind of thing. I was listening to a review of it when I was driving down to Canberra, which talks about there is an underlying niceness about humankind, although we are competitive as well, and evolution's driven us that way. The survival of the fittest. The ones who can beat up their enemies the best are the ones who survive. And they write the history books too, as we well know.
Yeah, that's probably true. Yeah. And I suppose our early escapades into another world would be, we come in peace, because we wouldn't be sending military people straight in.
You would hope
not.
No, you would hope not.
Yeah. But, science fiction always looks at the dark side of things. So, that's probably where my brain is.
I should just mention, talking of such things, that I said that the Questacon space exhibition opened yesterday, and yesterday, of course, was May the 4th. And that was why. So there was a very strong Star Wars theme, and I got to stand next to Princess Leila's sculpture. I don't know whether you're familiar with that, but it's a rather spectacular abstract sculpture, basically looking like a string of DNA. I got a picture of me standing right beside it, which is on my Twitter feed.
Okay. Oh, wonderful! There you go. We're going to take a little break, but when we come back, we'll be talking more about some strange things in our universe here on the Space Nuts podcast with Andrew Dunkley and Fred Watson.
Space Nuts.
Now, have you visited our Space Nuts website in recent times? You should. I mean, not only can you listen to the Space Nuts podcast and all our back episodes there, you can go up the top and there's a whole string of links. Astronomy Daily, which constantly updates people on space, astronomy and science news, sometimes a little bit out of left field, but a lot of the mainstream stuff gets a mention there. There's also the AMA tab where you can upload your audio questions or your text questions. There's the Space Nuts shop, of course, where you can look at all the goods that we offer for you, from T-shirts to caps to cups to silly little books and so on. And a bit of information about supporting Space Nuts in whatever form you desire, whether that's as a patron or as a one-off donation or through the shop. So just have a look at it, spacenutspodcast.com. That's our website, spacenutspodcast.com. Now, Fred, we are going to talk now about this unusual phenomenon, which has been affectionately referred to as space blobs. Now, these space blobs appear to be sort of galactic in nature. Some kind, I believe they're quite large, but they're more of a ghostly type of apparition than they are a galaxy as such. So they've been affectionately called space blobs. Do we know much about them?
No, not really. And they're a relatively new phenomenon. And in fact, their technical name is as entertaining as the blob name. They're called odd radio circles. And I actually know some of the researchers who've done this work quite well. And one in particular, Professor Ray Norris, who's an old friend of mine, odd radio circle is exactly the kind of thing that Ray would describe something as, and so I'm sure that's where the name came from. This is work that's...
I, on the other hand, am an odd radio presenter, so I can understand.
Yeah, and they don't come much odder.
No.
So this work goes back a couple of years, actually. In fact, I think it was last year that the first reports came in from data collected the year before, and they come again from the observatory that I've mentioned already, the Australian Square Kilometre Array Pathfinder, an array of I think 13 or 14 metre dishes, maybe 12, I can't remember, which are at a place called the Murchison Radio Astronomy Observatory in remote Western Australia, one of the most radio quiet places on the planet, until the mega constellations of satellites go past. That's another story. But the ASCAP, the Square Kilometre Array Pathfinder, has done some fantastic work. For example, in the fast radio burst science, they've contributed a lot to that. But this is another of their discoveries, and the group that are working on this, led by a scientist from Babel, who I know reasonably well, based at CSIRO and at Western Sydney University. Babel Korybalski, I didn't give you... Oh, sorry, Babel, I guess it is, because there's an umlaut there, of CSIRO and Western Sydney University, has led the group looking at these strange circles that have been found, the ORCs, or odd radio circles. So the story, the backstory is, I think 4 were found in their original survey for these things, but another one has now turned up. It's got a fabulous name, DESJ010224.33 minus 245039.5, which tells you exactly where in the sky it is, because those numbers are its coordinates on the sky. And that's what they are. They're circular structures at radio frequencies. You probably don't have to look too far to find an image of them. I'm actually looking at the Science Alert website, which has got a report on this. Astronomers detect another mysterious ghostly circle in extragalactic.
It looks like a topographical map.
Yeah, well, that's the radio intensities. Radio astronomers tend to, certainly at low frequencies, they tend to show their images, which look like contour maps, exactly as you've said. But this is overlaid with the same area of sky at different frequencies, probably optical and maybe even X-ray or something like that. And you can see that there is evidence that this thing has a circular structure. So one of the things that you can't just find out from these ORCs is without kind of taking other things into consideration. You can't get their distances. And that's, if I am remembering correctly, is because they're essentially, they're not emitting single frequencies. They're what you would call a continuum, a radio continuum observation, and that doesn't let you work out the redshift, which doesn't let you get the distance. However, with this new one, DESJ01, etc., what the team have found is an elliptical galaxy right in the middle of it. It's a radio galaxy, so it emits radio waves. That means it's probably got a black hole in the middle that's churning up stuff. But it's in the dead center of this ORC. And that could be a coincidence, except that two of the other four of these objects, which were published last year, also have one of these elliptical radio galaxies right in the center. And I think they've worked out that the odds of that being a chance alignment, a 1 in 200 or thereabouts. So it looks as though this is telling you something. And in fact, the first thing that you can do is say, okay, if this ORC, if this radio blob, this odd radio circle, is associated with that galaxy, then you've got its distance, because the galaxy, you can actually measure its distance, and that, if the circle is associated with that, then you get the distance, and once you've got the distance, you can tell what size this thing is. So the new one that's been discovered, they get almost 1 million light years as its diameter, and that's big. When you think the distance between our galaxy and the Andromeda galaxy, our nearest large neighbor galaxy, is 2.5 million light years. If you imagine our galaxy with one of these circles around it, it would be halfway to the nearest galaxy. So it's the nearest big galaxy. So that's telling you something. What these scientists do is propose 3 possible emission mechanisms. One is, and I wonder if this might be the answer. The first one that they've thought of is if you're looking end on to what we call a radio lobe from one of these radio galaxies. And what I mean by that is that when you look at galaxies, these what we might call active galaxies, which are in fact the elliptical radio galaxies, they're bright in radio frequencies. Often they've got these 2 jets coming out of the center, and that's stuff being emitted by the black hole. That stuff kind of hits what we call the intergalactic medium, the very rarefied plasma that surrounds galaxies. It hits that stuff and spreads out into a big bubble. So there are several of these radio galaxies. When you look at them, there's a blob of radio emission in the middle. There's these 2 jets coming in opposite directions out of the nucleus of the galaxy, and then a kind of bigger amorphous blob on the end of one of these jets, which is, as I said, where this material collides with the interstellar medium, the intergalactic medium. So if you imagine that we are looking end on at one of these radio lobes, maybe that is what we're seeing. It's one of the possibilities. And because they're end-on, they look circular. The other two suggestions, one is a giant blast wave from the central galaxy, but they struggle to get the amount of energy that you'd need to form that blast wave. They suggest perhaps something like two supermassive black holes merging, which will be certainly a gigantic effect. And the other one is just simply an interaction between a radio galaxy and this intergalactic medium I've been talking about. But that's, you'd expect if a galaxy is moving through that medium and something's happening to cause radio emission from its surroundings, you'd expect it to be distorted. You wouldn't expect a perfect circle. So they sort of rule that one out. So, we know of 5 of these things now. They're odd radio circles, very odd, and people are struggling to explain them. So I think this is one of these things that you and I will probably talk about again down the track, Andrew. Yeah.
And I guess having found 5, it would be a fair assumption then that these are numerous.
Yeah, that's right. There's lots more of them. And, another line of research with this is to observe them at different frequencies, because that's always the thing that lets you piece together the jigsaw puzzle of what's happening. You observe them in X-rays, visible light, infrared, anything you can get hold of.
Yeah, well, I love the name Odd Radio Circles. Space Blobs works for me too. Anything along those lines, I'm happy with. But lots to learn by the sound of it. You're listening to the Space Nuts podcast, or you might be watching us on YouTube. That's your bad luck, with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Once again, I want to say thank you to our patrons who financially support the Space Nuts podcast. And if you want to become a patron, you can do so via our website. Just click on the supporter button and find out how you can support us. It's not very expensive. A few dollars a month is all that we ask. But if you want to give more and more and more, that's up to you. The option is available. Now, you can do that through patreon.com. You can do it through Supercast, or you can do it through other entities, which are all noted on our website. So just hit the supporter button at spacenutspodcast.com to find out how you can become a patron. We are certainly looking to become 100% patron supported in the future. So, if you would like to help us achieve that goal, sign up today. It's purely voluntary. I will always tell you that. You don't have to do it, and we will still provide our program to you as is. Now, Fred, it's time to answer some questions, and our first comes from Michigan. This is Bill.
Hello, Andrew and Fred. This is Bill from Ann Arbor, Michigan, with a question about special relativity. This is a thought experiment that seems to result in a paradox, and I hope that you or any of your physicist friends could resolve it for me. So a meter stick is flying through space, end on, like a spear. Coming at it from the opposite direction, edge on, is a very thin, flat sheet of metal with a 1 meter diameter hole in it. They are approaching each other at half the speed of light. The sheet of metal is also slowly moving in a direction perpendicular to the line between the two objects, so when they meet, the meter stick should just intersect the hole in the sheet metal and not hit the sides of the hole as it passes through. Using Lorentz-FitzGerald contraction, relative to the meter stick, the sheet metal should be shrunk by 13.4% in the direction of travel, so the whole of the sheet metal is only 86.6 centimeters wide. The meter stick will definitely collide with the sheet metal. But relative to the sheet metal, the hole is 100 centimeters across, while the stick is now only 86.6 centimeters long, so it should easily pass through the hole in the sheet metal, easy peasy. Which actually happens? Thanks for your great podcast. Keep up the good work.
Thank you, Bill. Very interesting question. Chicken and the egg, basically. No, not quite, but
it is. Yeah, it is interesting. So, thinking about this, and what I'm now envisaging is that the stick is just slightly tilted to its direction of travel, and the sheet is just slightly tilted to its direction of travel, so that in the absence of any relativistic effects, they would pass through one another. The stick would pass through the hole. So it all comes down to what you call reference frames. So for a stick traveling through space, its size doesn't change from the perception of somebody holding the stick. Yeah. It only changes in relation to a stationary observer. And if you've got something going the other way, that has the same phenomenon. So if you're a stationary observer, you're watching these two things collide. And by the way, half the speed of light plus half the speed of light does not make the speed of light.
As we discussed
last week. That's right. But the phenomenon would be that the two would actually, I think they'd pass through one another. From my, I think the stick would be, if the hole was bigger than the stick at rest, the stick would pass through the hole.
Yeah, I thought there was going to be a but.
No, I don't think there is a but. I think that's what would happen. Yeah, I'm trying to do the thought experiment myself in my head.
Yeah, I'm having trouble.
It is all about
picturing it.
I mean, I guess what you have to do is look at think about the reference frames. Once again, there are three reference frames involved. There's the reference frame of the moving stick, there's the reference frame of the sheet with a hole in it, and there's the reference frame at rest from a stationary observer's point of view. So the reference frame of the of the stick of the sheet with a hole in it, it sees the stick coming towards you, foreshortened because of special relativity, so it easily passes through the hole. I think the answer is it goes through all right. I'm sorry, I'm kind of grasping at straws a bit here, but it's a really interesting question.
and that
our listeners are far too clever for us, Andrew.
Yes, I understand that.
Yeah.
And that is called the Lorentz-FitzGerald contraction. Is that what that is?
Yeah. So Lorentz-FitzGerald contraction it's what I just described. If you think of something like a stick moving along, it's like a spear through space at very near the velocity of light, then you see this contraction. Once again, I keep mentioning this new book of mine, but I put a cartoon in there showing an express train travelling at nearly the speed of light. It's a very old express train with a smoky engine and a driver who looks as though he's slightly startled, but it's very short, and it's a cartoon quiz because you've got to guess what its speed is from just the shortening. So that's called Lorentz-FitzGerald contraction, and it's called that because it was deduced actually before Einstein got to the issue. If you take the assumption that the speed of light is always constant, which we discussed last week, then Lorentz, who was German or Belgian, I can't remember, and FitzGerald, who was Irish, these are two physicists who said, well, the things must appear to contract. But it was Einstein who kind of sorted it out and really dotted the I's and crossed the T's with his theory of special relativity. But yeah, it's a great name, isn't it? Lorentz-FitzGerald contraction.
Indeed. And thank you very much, Bill, for the question. Let's move on to our next question. This comes from Chris.
Hey, Fred and Andrew. This is Chris from Canberra, Australia. I've been reading and thinking about the impact of the Starlink satellite constellation is having on the night skies and the astronomical community, and perhaps how Starlink could give back to that community. So what if each satellite had on its backside, that's the side facing away from the Earth, optical and radio sensors? Each sensor would operate independently, information being relayed back to Earth. Once on the ground, this information could be combined using software and AI systems, to, in essence, create optical, infrared, and radio telescopes the size of the Earth and looking in all directions simultaneously. Such a system could provide simultaneous access to many different users for many different purposes. So, for example, we could have 24-hour monitoring for asteroids and comets, perhaps using an AI system, while somebody else is doing a lunar survey. And meantime, you've got a classroom learning astronomy and using it to look at constellations that are not normally visible to them. I'd love to hear your thoughts and comments on the concept. Keep up the good work. Chris.
Thank you very much, Chris. Lovely to hear from you. Getting Starlink to give back a bit like that. I mean, that's not dissimilar to what we were talking about with the Quasar satellite technologies, multifunctional approach to satellite communications in space. But Starlink, it's primarily there to provide internet services in the world through a satellite network approach. Could they do something like this? Could they value add to their technology?
I'm not sure that they could, because I think in principle, I get what Chris is saying, and it's a nice idea, but I think it would just be the physical reality of doing this that makes it difficult, because sensors of the kind that you'd need to do anything useful are not just like this chip in your camera. You'd need, really, to make anything worthwhile, you'd need quite large pieces of kit, which would, probably modify the design of the satellites a lot. So Starlink satellites, for example, they're relatively small. They weigh 1/4 of a ton. They're pretty massive things. But all that is aboard them is designed for the transmission of radio signals between Earth and the spacecraft. If you were talking about adding radio telescopes to their backside and optical telescopes, you're suddenly talking about much bigger entities, and it would be not that straightforward. The other thing, of course, is that these things do change their angles as they're flying. Their orientation is controlled in order to maximise the coverage of the landscape below, and that's one of the things that's been proposed to try and avoid these mega constellations beaming signals into sensitive radio telescopes like the ASCAP one that we've mentioned several times in this podcast. So I think it's a nice idea. And we already know about telescopes the size of the Earth being synthesized in radio frequency. It's a lot harder to do it, by the way, at optical wavelengths. Optical arrays are a much different kettle of fish from radio arrays, and that comes about because of the way you detect the radiation. Fundamentally different. And but you could think about a radio telescope array on the back of these Starlink satellites, for example. I think there might be issues with interference, because even though your radio telescopes are looking out into space, you're right next to a set of high power transmitters which don't just beam their radio radiation in the direction that you want them to. They leak all over the place. So I think that would be a bit of a difficulty as well. But thank you for the suggestion. A nice idea, but I suspect not practical.
No. Check out with Elon, though. Just send him a note.
That's
Message
right.
him on Twitter. Yeah, he might go, it's a good idea. I won't do it with Starlink. I'll just send another 60,000 of them up there and do it separately. That's
Starlink
what I'll do.
2.
Yeah. Of course, Starlink is starting to make its presence felt over Australia now, because I believe it is available to people living on the 32nd parallel, or the 32nd degree latitude. So it's starting to roll out in Australia, and I believe it'll be available in Sydney this month, or is it next month? So, it's starting to happen here. Of course, it's available in many other places around the world as well. One of the downsides of Starlink technology, Fred, that I heard is it's not very the gear on the ground that you have to get attached to your place, which comes in a box and you have to set it up yourself in a lot of cases, is it's temperature sensitive. So in outback areas where the temperature gets well up towards 50 degrees, it could struggle. So it will be interesting to see how well it copes with our conditions. But, it's happening. Aside from the controversy that obviously people such as your good self see with Starlink and the other services that are being put up there in terms of light pollution and the encroachment on radio astronomy and all those other issues. Hopefully there's room for everybody. That's what I hope. I know they're trying to take it into account, but
compromise all along the way.
Indeed. Chris, thanks for your question. Lovely to hear from you. And don't forget, if you have a question for us, go to our website, spacenutspodcast.com, click on the AMA tab at the top, and you can record your question using your voice. If you've got a microphone in your device, whether it's a smartphone or a tablet or a computer, you can record it for us, and don't forget to tell us who you are and where you're from, and your question, of course. We got 20 questions the other day with everybody saying who they were and where they were from, but there were no questions. But that's fine. But you can also send us your question via our text uplink, our email uplink on the same tab, AMA tab on spacenutspodcast.com. We welcome them all. And Fred, that brings us to the end of another episode, 251. Thank you so much. Lovely to catch up again.
Yeah, great to talk. And we'll do it again soon.
We will indeed. That's Professor Fred Watson, Astronomer-at-Large, from Space Nuts, and from me, Andrew Dunkley, and Hugh in the studio. Thanks for following us. Don't forget to tell your friends about us, and we'll catch you again next week on another episode of the Space Nuts podcast. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.